So are you trying to learn more about lists related to Java? If so, this video will go over multiple topics related to lists, including what are lists, the list interface, the ArrayList class and the LinkedList class, working with list operations, sorting and searching lists, list iteration, list algorithms, performance considerations, as well as some coding snippet examples related to lists. So let's just get into it and let's talk tech with Tyler. So the technical definition of a list is a linear data structure that represents a collection of elements arranged in a specific order. Each element is associated with an index, which is used to determine the position within the list. So lists are fundamental data structures used to store a collection of items of various data types, making them indispensable in various programming languages like Python, Java, and more. So the first benefit is dynamic size. So lists have the remarkable ability to dynamically adjust their size. Unlike fixed-sized arrays, lists can grow or shrink as we add or remove elements. This flexibility makes them ideal for scenarios where the exact collection size is uncertain or changes over time. Dynamic sizing ensures efficient memory utilization, reducing unnecessary memory allocation, and improving overall performance. The second benefit is indexing. So, a fundamental advantage of lists is their efficient indexing mechanism. So, each element in the list is assigned an index, starting from 0 for the first element. This indexing allows us to directly access elements based on their position, enabling quick retrieval and manipulation of data. So it simplifies algorithms and reduces the time complexity for search operations, making list operations more efficient. The sequential order is a third benefit. So lists maintain the order of elements as they are inserted with their index. So this means that the elements are stored in a sequential manner, preserving their original arrangement. So this sequential order is crucial for applications where the chronological arrangement of items matters, such as managing timelines or to-do lists. It ensures that elements are easily accessible and processed in the same sequence they were added. Another benefit is dynamic insertion and retrieval. So lists offer dynamic insertion and removal of elements. So we could easily add new elements at any position within the list or remove existing elements based on their index or value. So this dynamic behavior makes lists ideal for implementing data structures such as queues, stacks, and linked lists. So a great example of a list is a queue. So for me, I have both Spotify and Apple Music. So either one, whatever music platform you use, whenever you add a song to a queue, that's a list. So it provides flexibility and efficiency in managing changing data requirements, allowing us to adapt to evolving needs. Duplicate elements is another benefit to lists. So lists gracefully handle duplicate elements. So we can have the same value multiple times within a single list, and the order of duplicates is maintained. So this feature is vital for various real-world scenarios, such as managing data sets, counting occurrences, or handling multiple instances of specific items. It basically simplifies tasks that involve managing and processing repeated data. Another benefit is versatility. So lists are incredibly versatile and find applications in various programming contexts. They serve as a foundation for more complex data structures and algorithms. Lists are commonly used to represent shopping carts, employee records, task lists, music, queues, and more. So their adaptability makes them sustainable for a wide range of programming tasks, making them a go-to choice for various applications. And last but not least, another benefit is powerful APIs. So lists come equipped with powerful APIs. And if you're not sure what an API is, it's an application program interface. I think of it as a handshake. APIs are like the handshake between two services. So these APIs offer a wealth of built-in methods and functions that facilitate easy manipulation, searching, sorting, and filtering of list elements. So leveraging the list API simplifies programming tasks, improves code readability, and enhances overall productivity. The APIs provide efficient ways to work with lists, reducing the need for custom implementations. So the list interface is part of Java's collection framework, and it represents a sequence of elements where each element has an index-based position. So in this slide, I list a bunch of methods that are in the list interface. So I won't go into detail with each of the methods listed on this slide. I think what would work best is going over some code snippet examples, and that way we could work through the methods. But here we have a few methods that are from the list interface. And this is part 2. There are some more frequently used methods that are included in the list interface. So the ArrayList class in Java is a part of the Java Collections framework and is an implementation of the list interface. It provides a resizable array-based data structure that offers numerous features and benefits, making it a widely used data structure in Java programming. So in this slide, we'll explore the key features and advantages of the ArrayList class. So feature number 1 is dynamic size. So one of the primary features of the ArrayList class is its dynamic size. So unlike arrays with a fixed size, array lists can grow or shrink dynamically as elements are added or removed. And this dynamic resizing allows the list to accommodate any number of elements without requiring manual resizing or memory management. So as a result, array lists offer efficient memory usage and adaptability to change data requirements. So the ArrayList class supports indexed access, enabling quick and direct access to elements based on their position in the list. A third feature is generic type safety. So ArrayLists in Java provide generic type safety, which basically means that they could hold elements of a specific data type, ensuring type safety at compile time. So when creating an array list, you can specify the type of elements it will store, and any attempt to add an element of a different type will result in a compilation error. This is helpful because this ensures that the array list remains type safe and reduces the risk of runtime errors related to data type inconsistencies. Another feature of ArrayList is the add and remove operations. So ArrayList class offers straightforward add and remove operations to manage elements. So these add and remove operations provide efficient ways to manipulate the ArrayList contents and maintain its dynamic nature. So I have a public class list, and then within that class, I have public class ArrayList operations. And within this class, we will go over some concrete use cases demonstrating ArrayList operations, such as add, remove, get, and more. So the first use case is create an array list of strings. So we will have array list, and then with the type, string, the name, we'll name it fruits, equals new array list. Add elements to the array. So to add an element to an array, you'll use the add method. So fruits.add, and let's just add some elements. So apple, all right, so we just added some elements to the array list named fruits. And now let's get the size of the array list. So let's declare a size, and size equals, and then fruits dot size. Perfect. So let's say we want to access elements using the get method. So let us initialize a string variable named first fruit. And let us get the 0th index of the fruit array list, which will be apple. And so say we want to modify an element at a specific index. So in the fruit example, let's say we want to modify banana and we want to make it grapes. So how do we do that? So we'll use the set method. Fruits dot set, and then we will give the index, so index 1, and then what do we want to set it as? So let's set it to grapes. So how do we check if an element exists in the array list? So we could use the contains method. So let's create a variable called contains mango, and let's see if this fruit array contains the word mango. So we'll do a Boolean value. And this will return true because the mango is the second index of the fruits array list. And so let's say we want to remove an element by index. So we will use the remove method. We could just do fruits dot remove and then the object that we want to remove. So let's say we want to remove mango, object number index 2. And we're good to go. And let's say we want to remove an element by value. So we will do the same thing, fruits dot remove, and then the object, which is mango. So how do we check if an array list is empty? There is a method called isEmpty. So let's do Boolean for this. We can create a Boolean value named isEmpty. Roots dot and then is empty, and that'll return true or false. And let's just say we want to just clear all of the elements within this fruit array list. How do we do that? We could use the clear method, roots dot clear. So now we have the LinkedList class. So the LinkedList class in Java is another implementation of the list interface, providing a linked list data structure. So it offers a set of unique features and benefits that make it a valuable choice for certain scenarios. So in this slide, we'll explore the key features and advantages of LinkedList class. So similar to ArrayList, linked lists also offer dynamic sizing. So this means that they can grow or shrink dynamically as elements are added or removed. The dynamic sizing of linked lists ensures efficient memory utilization and allows them to handle collections of elements whose size changes frequently or is not known in advance. A second feature is efficient insertion and deletions. So linked lists excel in providing efficient insertions and deletions. However, unlike array lists, where inserting or deleting elements in the middle requires shifting elements, linked lists maintain reference to the next and previous element, making such operations more efficient. So this feature makes linked lists particularly suitable for scenarios involving frequent insertions and deletions in the middle of lists. The third feature is flexible memory allocation. So linked lists use memory more flexibly than array lists do. And that's because each element in a linked list is represented by a separate node, which contains both the data and a reference to the next and or previous node. So this flexible memory allocation allows linked lists to store elements non-contiguously, reducing memory wastage and enhancing efficiency. So unlike array lists, where the array list has the next array with its next index, linked list is sort of like, it's literally links. And that's what made me remember it, remember this class, is think of it as links. So a chain has links, and we can insert a link or we could remove a link. A bracelet, for example. Sometimes we need to remove some links. So with a linked list, you could add or remove links in the middle of the linked list. And the reason why is because each link has its previous link information as well as its successor link. So it basically has its left link information as well as its right link information. So the fourth feature is no array resizing overhead. So as we have said with the other three, as we have mentioned in the other three features of a linked list, unlike the array list, linked lists do not require array resizing when elements are added or removed. So as each element is stored in a separate node with its own references, there's no need to resize an underlying array. So this property eliminates the overhead associated with resizing arrays, resulting in faster and more predictable performance. So another feature of the linked list array is iterating and traversal. So linked lists offer efficient iteration and traversal since each node maintains references to the next and or previous node. So traversing the linked list can be done quickly. And this makes linked lists suitable for scenarios where frequent iteration over the elements is required. So removing the first element involves updating the head reference, while removing the last element involves updating the tail reference. So these operations can be performed in constant time, making linked lists efficient for certain use cases. So on this slide, I list common list operations. I won't go into detail for each of these operations. I think what would work best is just doing some code snippets. So I'm going to be going over some linked list operations in this coding snippet. And as you can see on line 1, we have import java.util.linkedList. So java.util, util is a utilities collection within the Java framework. And the linked list is a part of the collection framework present within the util package. So let us create a linked list of integers. So we'll do linked. So as you can see here, we have some options, and these options come from the util package that we explicitly listed on line 1. So we could just use the second option, and double click, it'll create the linked list. And then now we're going to give it the data type that we want, so integer. And then we'll name it, so let's name it numbers equals, and then new linked list. There we go. And so now we've created a linked list of integer type. And so now let's just add some elements to this numbers linked list. So to add an element, we could use the add method of the linked list collection. So numbers dot. So as you can see here, we have a bunch of methods that are possible to us, but we want to just use the add method. So add, and then we will add, let's add 10. And let's just do it 3 more times. So numbers 20. All right, so now we should have 4 integer values within the numbers linked list. So to get the size of a linked list, we could use the size method. So numbers dot, if we scroll down, we should see size. There we go. And this will give us the size of the linked list. And also, if you want to, if you're testing this out at home or anything like that, if you want to see the actual size of this, there's two ways you could do it. So you could initialize a integer variable. So we could say int size equals, and then we could print it out. So system print, and then size. And this will print out the size of the linked list. You could also just do this. So whatever works. I like the first option a lot better though. All right, so let's access elements using the get method. So we'll do the get method. So numbers dot get. And let's access the first number, so the 0th index. And so how do we modify an element at a specific index? So to modify an element, we will use the set method. So numbers dot set. And let's set the first index to 50. So to check if an element exists in a linked list, we can use the contains method of the linked list. So numbers dot contains. And then let's say, does it contain 30? This will return true. But again, if you would like to test this out on your own, we could, for example, create a Boolean value. Boolean contains 30 equals, and then we could print it out. All right. So next up, how can we remove an element by its index? So to remove, you will use the remove method. So numbers dot remove. And keep in mind, if you were looking at the coding snippet for ArrayList, this is pretty similar methods. And so let's remove the first occurrence of a specific element. So we will use the numbers dot remove. And if you notice, there are some other methods available to us. And here it is. Remove first occurrence is a method available to us. And what do we want to move the first occurrence of? Let's remove the first occurrence of 40. There's only 140 in our array list, but let's pretend there's more than 140 in our array list. And let's check if this array list is empty. It'll be another Boolean value if you want to print this out. But we could just use the isEmpty method, numbers dot is empty, and this will return true or false. And then to clear all elements from the linked list, similar to the array list, we will use the clear method. So keep in mind, as I said before, many of these methods are similar to the array list. All right, so sorting and searching. How do I sort and search through lists? Here are some commonly used operations. Again, I won't go into description. You can pause the video if you would like. So iterating over lists is a common operation in Java programming when we need to access and process each element in the list. So in this slide, we'll explore three methods for iterating over lists: the enhanced for loop, the iterator, and the list iterator. So each method offers unique advantages and use cases, making them valuable tools for list traversal and manipulation. So the first method we have is the enhanced for loop. So the enhanced for loop, also known as for each loop, provides a simple and concise way to iterate over elements in a list. It eliminates the need for manual index management and directly iterates over each element in the list. The enhanced for loop is best suited for scenarios where we need to process all elements sequentially without requiring access to the index. So the second method is the iterator. So the iterator is a more flexible way of iterating over lists, as it provides explicit control over traversing the list and allows for various operations such as adding, removing, and modifying elements while iterating. So the iterator is suitable for scenarios where you need to perform complex manipulations on the list during traversal. And a third method is the list iterator. So the list iterator extends the functionality of the iterator specifically for lists. So this allows for bidirectional traversal, meaning we can move both forward and backward in the list. So this method is useful when we need to traverse the list in reverse or perform complex operations that require access to both the previous and next elements. So now that we've discussed those three methods, iterating over lists in Java can be achieved using the enhanced for loop, the iterator, and the list iterator methods. So the enhanced for loop is a concise option for simple sequential traversal. The iterator offers more control and flexibility, allowing complex manipulations during traversal. The list iterator extends the capability of the iterator, enabling bidirectional traversal and advanced list operations. So choosing the appropriate method depends on the specific requirements and operations you need to perform during the list iteration. So here we have a few list algorithms and utilities that are commonly used. So I just went over linked lists, array lists, all of the lists, and we need to always keep in mind the performance considerations. So when working with lists in Java, choosing between either the linked list and the array list can significantly impact performance based on the specific operations you will be performing. So in this slide, we'll explore the performance considerations for insertion and deletion at the start, end, and middle, random access / element retrieval, memory overhead, resize expansion behavior, iteration performance, and search performance. So for linked lists, insertion and deletion at the start and end of a linked list, the linked list would be the best option. Insertion and deletion at the start and end of a linked list are very efficient as they involve updating the head or tail references. However, insertion or deletion in the middle requires traversing the list to find the target position, which can be slower for large lists. As for the array list, insertion and deletion at the end are very efficient as it requires only appending or removing elements from the end. However, inserting or deleting at the start or middle requires shifting elements, making it slower than the linked list for these operations. So the next consideration we have is random access / element retrieval. And the best list to use for this is the array list. So with the linked list, random access or element retrieval is less efficient compared to the array list because accessing elements in a linked list requires traversing the list from the beginning or end, resulting in higher time complexity for random access. Therefore, with the array list, it's very efficient as it uses direct indexing. So accessing elements by index has a constant time complexity, making it faster for linked lists for random access. Another consideration is memory overhead. And the array list will result in lower memory overhead. So the linked list has a higher memory overhead than the array list because each element in a linked list requires an additional memory allocation for the node object as it stores the data and reference to the next and or previous node. The array list, on the other hand, has lower memory overhead as it stores elements in a single contiguous array without the need for separate node objects. Another consideration is resize or expansion behavior. So the linked list does not require resizing or expansion as it can grow dynamically without any fixed capacity. The array list may require resizing and or expansion when its size exceeds its current capacity. And resizing involves creating a new array and copying elements from the old array, resulting in an additional overhead performance. Another consideration is iteration performance. So for linked lists, iterating over a linked list can be slightly slower than an array list due to the extra overhead of following node references. So the array list provides faster iteration performance because it allows direct access to elements through indexing, leading to a more efficient traversal. Another consideration is search performance. So with linked lists, searching for an element in a linked list requires linear traversal, making it slower for searching compared to an array list. An array list offers faster search performance, especially for large lists, due to its constant time random access, making element retrieval by indexing much faster. All right, so that was everything. If you enjoyed this video, please click the thumbs up button down below and also subscribe to my channel. I do post regularly, and as well as hitting the like button and the subscribe button, leave a comment down below. Let me know what you kind of understood the most, what you understood the least. Also, leave any suggestions that you have for me. If you enjoyed the video, let me know. If you have any suggestions for me, let me know. I do and will look at all the comments. I also have cheat sheets if you want all of the topics that I covered on this video in a one-page cheat sheet. Go to my website, tylerlcrawford.com, linked in my description, and you can purchase a one-page cheat sheet that I've made that has all the information from this video on my site. But once again, I hope you enjoyed this video. I hope it was helpful for you, and I will see you in the next video.